Math boxes, page 49. All right, so looking at problem number 1, remember we do what's inside the parentheses first according to the order of operations. 3 times 4 is 12. 18 divided by 3 is 6. And 12 plus 6 is 18. Number 2, interior parentheses, 3 plus 2 is 5. 5 times 7 gives us 35. And 35 minus 20, 15. C, interior parentheses first. 81 divided by 9 is 9. 9 divided by 3 is 3. 9 divided by 3 is 3. And 2 times 3 is 6. Number 2, write a 5-digit number with a 6 in the ones place. There are no decimals, so the ones place will be all the way over here. A 3 in the thousands place. A 1 in the hundreds. A 8 in the 10,000s. What am I missing? 6, 3, 1, 8. Oh, it's a 5-digit number, but they've only given, oh, there it is, a 0 in the tens place. I was going to say, if they didn't give us one, I was going to put a 0 there, because to have a 5-digit number, we would have to have 5 digits. This one looks a little complicated, but we're just going to break it down one piece at a time and see which ones, which expressions show 3,200 or 3,248 in expanded form. So 32 times 1,000 would be 32,000. Well, I've already got too much, so that's not going to work. 4 times 10 would be 40, plus 8 times 1 would be 8. That would be incorrect. How about 3,000 plus 200 plus 40 plus 8? I'll add that over here. 3248. So that one works. Darken it in. 3 times 1,000, 3,000. 2 times 100. 4 times 10 plus 8, 3,248. That one also works. And 3 times 10 to the third, that's 3 with 3 zeros. 2 times 10 to the second. 4 times 10 to the first. And 8 with no zeros, 3,248. Looks like there are 3 that work for that one. Find the volume of the prison. Use the formula volume equals length times width times height. Well, it's 2 across, it's 2 deep, and it's 1, 2, 3, 4 high. So let's say it's 2 times 2 times 4. 2 times 2 is 4, and 4 times 4 is 16. And notice that it's units cubed. Number 5, write in exponential notation. 1, 2, 3, 4, so 10 to the fourth. 1, 2, 3, 10 to the third. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm going to double check that just to make sure I counted correctly. Let's start this way this time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yep. 10 to the 11th power. It's a pretty big number. Number 6. Asher used 5 apples to make an apple pie. To make a jar of applesauce, he needed twice as many apples as he needed for the pie, plus 2 more. Write an expression that models how many apples Asher needed for the applesauce. So he used 5, and to make a jar of applesauce, he needs twice as many apples as he needed for the pie. Okay, so that would be 10 apples. Used 5 for the pie, he needs twice as many, plus he needs 2 more. So an expression, and we'll solve it, 12 apples.